Clients off the get-go will not always realize they have a need for a real-time dashboard or an API-based solution, but sometimes, 6 months, a year, 2 years after the implementation, clients will realize they do have a use case for a real-time dashboard or real-time solution.
Welcome to Actualizing Success. In this podcast series, our in-house advisors discuss today's finance and technology topics with an emphasis on solutions that embrace tomorrow.
Welcome to another episode of the Actualizing Success podcast. With the global trend in identifying automation, machine learning, and AI opportunities, we'll be discussing a prerequisite to obtaining that goal, which is data strategy and Treasury. To introduce myself, I'm Don Boyle, Senior Consultant with Actualize, and I've been with the firm for 2 years with a focus on bespoke solutions, such as leveraging APIs to build integrations across systems for a specific functional use case, or to generate analytics and reporting from your data. I'll ask my colleague Will Robertson to introduce himself and our topic for today as well.
Thanks, Don. My name is Will Robertson, and I am a Senior Manager with Actualize Consulting. I have, in my 6 years at Actualize, worked across a lot of our different functions inside the capital markets department. But as of recently, I have worked a lot with Dom on sort of identifying sort of these clients that may fit bespoke opportunities. So we have spent a lot of time talking about getting a client ready for, their data strategy so that we can take on some of these new innovative ideas. Like Dom mentioned, we're going to talk about data strategy today and put an emphasis on within your Treasury organization, how to make that data strategy work. So let's first define what data strategy is. So it's a comprehensive organization-wide plan that aligns how data is collected, managed, governed, and even utilized with your overarching business goals. So then I think I'd like to ask the question, why does data strategy matter for Treasury? I think it's important to establish processes and systems to collect, integrate, and analyze financial data from different various sources to improve cash management, risk assessment, and strategic decision making. So it's important to utilize all your different systems, your treasury management system, your FX trading platform, if you've got an AR or AP systems, and even a hedging system if you're using that. Utilizing all that data will help make the most effective picture of your current business's financial state. We then bring in the question, okay, now that we've centralized that data, what is the ideal in-state goal of getting this data strategy in place? I think it's to have confidence in the ability to view your data across all those systems I mentioned in a centralized location and make financial decisions in a timely manner. When you can do this, you also have the opportunity to add in some of these bespoke, innovative new solutions like machine learning, AI. We'll mention some use cases in a moment here. For a goal, I'd like to give a few examples of what having that data strategy in a organized manner would look like, right? So I think when you have all the systems speaking with each other, you can answer questions like, what should my minimum cash balance be for a subset of accounts? Or what should a future forecast related to AR look like? And how can I apply some sensitivity analysis moving it up and down 5%? Just a few examples to look at when you're thinking about why set up this data strategy. I'm next going to hand it over back to Don. He's going to look at kind of how some steps to get that data strategy in place in your organization.
Awesome. Thanks, Will. So We have a 5-step process to build your organization's data strategy. So we have 4 steps of validating data in systems, building a MVP, so a minimum viable product, or POC for your enterprise data lake, building a data schema, and finally consolidating your data across systems. So those first 4 steps are what you'll need to really just build or implement the data lake. However, then Will's going to walk through a additional 5th step of data governance. And then we'll both talk about some AI and machine learning use cases together. So the first step that we wanted to talk about was validating data in systems. So I guess to first introduce this, the current state is that your systems are forming data silos across your organization, right? We have a system here, a system there. They don't necessarily integrate. Perhaps they do for certain data type, definitely not for everything. But that forms a data silo across your system, right? And I think at this point, we can all agree that building an enterprise data lake is the ultimate goal, right? To marry all that data together. But before we do that, we have to validate the current state data across systems, especially core data, right? So for example, if your ERP was implemented in 2005, for example, or even earlier, and your TMS was implemented 10, 15 years later in 2020, likely not all the core data in your ERP will be up to date, so a full validation should occur, right? So before we marry all that data, we should be sure that we validate all that core data to make sure it's accurate. And where any system's data is inaccurate as you're going through this validation process, I think it's important to think about root cause and how that issue can be resolved going forward. Because as we get into the later steps, right, we'll talk about automated monitoring of this core data as well as data governance, right? So I think it's crucial that as you go through the validation process, we identify what the root cause is. So later on, when we set up our governance process, right, we're able to think about those root causes earlier and think about how we can rectify that going forward. So the next step that I wanted to talk through was building that minimum viable product or POC towards a data lake goal, right? So I think it's important to think that building an enterprise data lake, it can take 1 or more years, right? As we'll talk through these steps, right? This is a lot of work, right? If we're just putting all the data together, it can be quick, it can be easy, but in terms of making sure that data is correct and validating it long term, you likely want to spend a lot of time building a spec and things like that. So chances are this process is going to take 1 or more years. And so as we're going through this process, we recommend building that MVP or POC towards the data lake goal. And that's taking data from one of your systems, putting it in a kind of mini data lake or prepackaged model, and then using that to generate insights, identify AI or machine learning cases, reports, and things like that, as the IT team or tech team is building out that enterprise data lake for you, right? So, for example, to Actualize, we do have a prepackaged Power BI and Kyriba-based solution. So really what this does is it uses the Kyriba Open API in real time, of course, takes data from your Kyriba instance and passes it to Power BI in a semantic model, right? So what this allows us to do is in the Microsoft environment, we have Copilot, right? That's an AI model. So we can use that data from your TMS to identify those AI use cases. Additionally, we can build reports in Power BI and reports in Excel as well. So it's direct connectivity, and it really helps you identify those use cases as we build an enterprise data lake across all your systems. A couple things to note is that the prepackaged solution that we built, it can be extended to other systems as well because it's entirely API based. And as we move on to these later steps, we'll see that this prepackaged solution, it helps to build the data schema for one of your systems. And this sort of MVP ensures a quick turnaround of a POC solution and allows the functional team to work with a subset of their enterprise data, which can eventually be reapplied to all of their enterprise data, so to the large data lake that we're building. And the logic used in this MVP can also be reapplied to our enterprise data lake as well. So that's the second step of building the POC. The third step is building a data schema. So just to give some context right on timeline, While the functional team is working on building dashboards and identifying use cases within their Power BI environment using that POC that's built, the tech team or IT team can work with system experts to create a data schema across all their systems. So that data schema will include something like common keys and elements to join between data tables across systems, defining consistent naming conventions for similar fields across systems. And really the output of this effort should be a detailed spec that can be referenced throughout the data lake build and post implementation as well, right? So even before we get to the build, a detailed spec is needed, just to make sure that we know how we're going to join tables and marry data across all of our systems of similar data types. And then the last step in terms of getting the build done is the actual build itself, right? So at this point, we have our POC. So while we were building our spec and while we're building our enterprise data lake, the team can use cases, dashboards, and really get buy-in from the entire functional team on this effort. And we've also have a detailed spec at this point as well as to how we're going to consolidate all of our data across our systems. So this final step is to actually build our data lake. So just to quickly talk through something more administrative or prereq here, we will need company resources for this step, right? So that includes IT experts and infrastructure as well. That infrastructure being a sort of data lake tool such as Snowflake or Azure to actually hold our data in a data lake. And, even before getting started on this data lake effort, we need to make a plan to hire these individuals if we don't have them today, or explain the time commitment required to the existing IT team that we have in place. And, once we're building this enterprise data lake, one other thing to keep in mind is how we're going to transmit that data. So, generally when we talk through this with clients in the current state, we talk through two options, right? SFTP or API. Generally, we recommend an API-based solution because it is most flexible, right? The API solution, it's real time. If there's ever a requirement that with the data across all your systems, you want to build a real-time dashboard. So for example, I click the refresh button, or at certain times per day, we want to automatically pull data from all our systems in real time. We want to use an API-based solution. Now, a lot of the times, I think Will and I, in working together, have noticed that clients off the get-go will not always realize they have a need for a real-time dashboard or an API-based solution. But sometimes, 6 months, a year, 2 years after the implementation, clients will realize they do have a use case for a real-time dashboard or real-time solution, right? So generally, we recommend where possible to use API-based transmission, just because it opens up a lot of use cases going forward, right? For example, if anything's API-based, it allows you to make real-time decisions with logic built in to those API calls, and you can make automated decisions. Whereas with SFTP, we're really just sending bulk data at certain times throughout the day. And sometimes that is all you need, but generally for future use cases and automation opportunities to get that real-time data, we recommend going towards an API goal. So that's really in terms of those first 4 steps. So at this point, we have a data lake that's active. I'll pass it to Will to talk through some of the data governance required in the process.
Yeah, so within all of the steps that Dom just mentioned, and even once the data lake would be built, you are going to want to maintain data governance throughout that process and throughout your entire data strategy initiative, right? So some of the responsibilities involved within the data governance functions are defining and enforcing different data policies. We're going to make sure that we maintain data quality and integrity, and ensuring data security and compliance. So an example would be enforcing an approval workflow to core data elements within our data lake, and how that data is transmitted, so that we know that anything sensitive, there are sort of controls around it. Some of the common roles you need to think about for your organization to maintain high data governance are a data governance lead, or I've heard it called a chief data officer as well. Essentially, this is an individual that sets the strategies, policies, and actions around this entire data consolidation initiative. We're also going to have data stewards. So these individuals will manage data definitions and quality for specific domains. Essentially, these are specific people that know a single system's data very well. And anytime a change or an update or new data is brought into that source system, these data stewards will be the subject matter experts to essentially get that extracted out and pull it into our data lake. We also have data custodians. So these are the individuals handling any technical infrastructure and security. So ensuring that data can be passed effectively, right? We mentioned if it's going to be either SFTP or API, but they would be making adjustments to get the new data elements, maybe that the data stewards brought on and passed through. They're also going to be ensuring that there is security around the transmission and extraction of the data from the different source systems into that data lake. And then finally, we have the data users. So these are going to be the individuals that utilize the data that come into the data lake, make those different financial decisions within your Treasury organization. But all at the same time, these same users are going to be adhering to the different governance policies that data governance lead or chief data officer sort of sets across the entire organization. So these four roles that I just mentioned are going to be working interchangeably with each other throughout the implementation of the data strategy, and then once it's implemented, even continuing on, right? So we're always going to have different controls and procedures in place so that we can have confidence that the data that's making our decisions is true. Some of the different controls would be the actual policies, processes, and technical solutions that manage and protect the different data. We would have controls that define who has access to what data elements, what actions they can take with that data, and ultimately under what circumstances can they take those actions, right? So I know I threw a lot at you there, but an example of a control would be something like data quality standards, right? So how common data elements must be entered into different systems, specific fields that need to be populated. You could have minimum or maximum character limits. You could have different data elements that must be defined as being either alphanumeric, straight numeric. If it's a date and time, right? We want the same date and time formats across systems, right? This all helps ensure that the systems are acting almost together as one whole in that data lake, and we're not having to do lots of different transformations of the data so that it fits into the sort of the puzzle piece that is the ultimate data lake. And then finally, another thing to look at is data permissions. So which data users can see which data elements. So for example, you may have teams within one business unit that should only see relevant financial data related to that specific business unit, right? So that might be specific bank accounts and balances around their business unit, a forecast only related to their business unit and not the company-wide organization. I've also seen this by region too. So you may have certain countries that individuals can sit over, and once again, they're just specific to whatever financial information occurs within that country that they would need to make decisions towards. Now that we've got our data strategy in place, we've implemented that data lake, and we've got a good data governance policies. Let's talk about some cool things we can do with it, right? So we're going to talk about different AI and machine learning use cases, and I'll have Dom first give a quick explanation of the difference between machine learning and AI.
Awesome. Thanks, Will. So I will say that the definition of AI versus machine learning does seem to be evolving daily, unfortunately, because it is a definition. But from what we know today, AI is the broad field that aims to create tools or systems that can mimic human intelligence and behavior, while machine learning is a specific subset of AI that uses algorithms to enable systems to learn from data. So we'll talk through a couple AI and machine learning use cases individually. So we'll start with the machine learning use case. So the first use case that we identified is forecasting. Now, this is likely my favorite machine learning use case, as I always find there's so much room for automation in clients' forecasting processes. Right, we always talk about variance between forecasts and actuals. And when we think about machine learning, right, where an algorithm is built to identify variance and identify patterns, I think that, eventually we can get to a place where if we're building a data lake, we can build these algorithms to read our variance, read our historical actuals, and build an automated forecast for us. In the current state, right, of, what we see without a data lake, right, occasionally we'll see that we build integrations from our ERP system to our TMS for specific forecasting use cases. However, at this point, we've already built a data lake, right? So this data lake, it has all the data in one place across all of our systems, allowing us to build a forecast using all of our enterprise data, using custom tailored machine learning models that I can read historical actuals and identify seasonality, for example, to build a forecast. Now, the beauty of this is with a machine learning model, what I can do is I can tailor our models to look for specific attributes, such as seasonality, cyclicality, year over year. And I can, for example, adjust this by a fixed percentage for inflation or at certain times of the year as well, right? The beauty of this is I can really tailor it. I can tailor my model for what we expect in our business. And not only that, but in the end of the day, machine learning, it learns based off its mistakes, and it will improve every month when we generate a new forecast. So once the forecast is built, it can be transmitted to our TMS to capture our cash forecast. But since this data is generated automatically through a data lake, it can also be transmitted to our other systems as well, right? So that's just another benefit of building a data lake and having this use case is when we generate a forecast, it doesn't only hit one system, right? Again, forming a data silo, but instead, when we generate that forecast, it can be transmitted to other downstream systems as well.
Right. So similar in the forecasting sense in that machine learning is going to look at historical data to project a forecast. The payments anomaly works similar in that you can have the model look at your historical payments, and you can have within that model set criteria to look for, and then have a sort of a percentage variance that it's allowed to go up to, right? And one example of how this would work is if you have over the course of a year, let's say, have made 50,000 payments, right? And within that 50,000, you've never made a payment to Russia before, right? And then you attempt to make a payment to a Russian supplier for the first time. Well, this model is likely going to stop that and say, hey, this payment looks so different than all of your others. Are you sure you want to double check that, right? And so that can be, used in different ways across amounts, payment types, like I mentioned, where it's going, the country, even bank countries, different beneficiary banks, right? You could set all these different criteria in that it will look to essentially find something that looks different within that percentage that we set. So you just get a second glance before potentially making a fraudulent payment.
Awesome. Thanks, Will. So we'll talk about some AI use cases, with the first use case being core data reconciliation and enrichment. So to take you back to step one of building a data lake, the first thing that we ask you to do in building a data strategy, right, is validating the core data in your source systems. So now that we built this data lake, this process can be somewhat automated. So what that means is, after we validated our core data and we put all of our core data in a data lake, it's possible that we missed something in that first step. Hopefully not, but it's possible. But right, as we update core data in our source systems, right? So for example, a lot of the times we see third parties being copied over from your ERP to your TMS. What happens is, when I execute a payment to that third party in my TMS, it's possible I had a failure for whatever reason. And so I have to update that third party's attributes. When I update the attributes of that third party in my TMS, that doesn't automatically reconcile to my ERP, right? So if I'm making an update in my TMS, that won't automatically, impact my ERP as well. So what can happen over time in these downstream systems is that your core data can become misaligned. So one of the big benefits of AI is that it's able to identify patterns. And so what we can do is, since all this data is in one spot in a data lake, we can feed this to an AI model, which can read all of these data types, right? We're talking all of our core data, and reconcile this across systems, so that if there's an attribute in my ERP that I have in my ERP, but it's not in my TMS, for example, I can have that attribute automatically copied or recommended to be copied in my TMS, right? So when we enrich any of our data in a downstream system, we can use AI to give a recommendation that enrichment is also applied to all of our downstream systems as well. So that's one big use case that we see, is that, especially when we're dealing with core data, it can be misaligned across all of our systems. And what we want to do is leverage AI in that case to give us a recommendation or automated enrichment of that core data across systems. Now, with that use case for AI, I'll ask Will to introduce root cause analysis for payment rejects and early error detection as well.
Yeah, this is one of the more cooler ideas I've seen with applying AI within specifically payments that are made out of a system that the finance departments or treasury departments control, right? So today, what we try to do without AI is build the payments that are going to the bank with the best spec ability that we have, right? And we can set that up, and we go through different testing methods, right? But we don't have anything that continuously is monitoring our payments after we sort of get into that go live state, right? So what we can do with AI is actually feed it the specs of, like, hey, for this specific payment scenario, like let's take a simple one, like SEPA payments that are made within the Eurozone. We can say, if we're making a payment out of a Deutsche Bank account and it's a SEPA payment, this is what it should look like. Feed it that spec. And then what we can also do is, as we have successful payments going forward, we can train the AI to say, here are more examples, right? The AI is learning of, specifically in the new form of payments, this ISO 222 files of what it needs to look at. And you can have it in place as a sort of a gate to look at your payment. And if a tag is out of place, or there's a missing information, or for example, with the SEPA, someone who tries to initiate the payment out of a GBP bank account. Well, the model knows that it needs to be euro only, so it would stop this payment, right? And essentially, instead of letting the payment get all the way to the bank where it would ultimately get rejected, you are now seeing the rejection in real time, and it would also be able to point out to you to say, hey, this part of the payment file does not look correct based on all the other successful payments I've seen for similar payment types, right? I can think of a lot of areas where this is helpful is missing data information for beneficiaries, right? If someone incorrectly enters a SWIFT bit code for an international payment, and it's not 8 or 11 characters, right? Like this root cause analysis would be able to identify that. I can think of if it's supposed to be an IBAN bank account, but someone enters just the bank account in its local country origin, right? This is where something that can be used to stop it, point it out, and fix it in real time before you have to have it reject, chase it back to the original team that implemented, fix that data element there, and push it back through the approval workflow again. Well, we just wanted to thank everyone for listening today. Hopefully you enjoyed and learned a little bit more about data strategy and, get you thinking about some items when building your own data strategy. Of course, don't hesitate to reach out to Actualize, send us a note. We'd be happy to discuss anything you heard on the podcast today or, other ideas that may have sparked out of listening today. But we appreciate it, and thank you for listening.
Thanks for joining us for today's episode of Actualizing Success. Make sure to visit us online at www.actualizeconsulting.com, where you can explore our service offerings. Don't forget to subscribe to the show on iTunes, Spotify, or your preferred platform. If you've enjoyed what we talked about today, please consider leaving a review and following us on LinkedIn. If you have any questions or would like to share your opinions with us, please send us a note at podcast@actualizeconsulting.com. We look forward to hearing from you.